name is Srihari Muralidharan, and this is my project, RadCube. RadCube has to do specifically with something known as a CubeSat. A CubeSat is a satellite specifically intended to be used by educational institutes like colleges and high schools that takes up dimensions of 10 centimeters by 10 centimeters by 10 centimeters. The idea behind a CubeSat is that it creates a specific set of rules that make it really easy for small or low-funded organizations like schools to be able to launch their technology into space. So last year, I worked on a CubeSat team of my own at my high school where we tried to design a CubeSat. The payload design process took forever. It was very time-consuming and very complicated, as most of us had learned engineering in our own classes, but we hadn't had any experience building satellites or building electronics for satellites. So that process was very complicated. But why do I specifically say the payload or the sensor suite? The reason, all other parts of the CubeSat is nearly industry standard among different types of CubeSats. So, for example, the flight computer or the battery system. Every CubeSat needs a flight computer. You can go to another CubeSat that already exists and use existing technology and tweak it slightly to meet your mission needs. The payload, on the other hand, is completely based on what your mission requires. So a lot of times it needs to be done completely from scratch. That process can be insanely time-consuming because there needs to be a lot of iterative development before a final product can be created. That's where my product, RadCube, comes in. It tries to solve this payload problem. The idea behind it is that it provides a modular payload system where there's one part of the payload, which is the main board, which consists of a microcontroller, a data logging system, and some basic amplification circuitry that is common amongst all types of payloads. Then it has a modular section which allows for different sensors to plug in and be used using the same system. This system can be used with a whole slew of sensors using the same 6 pins for communication. The reason why this product is new and unique is because it keeps a low profile and is very space efficient. On CubeSats, space is a huge concern, specifically because the total volume that you have is relatively small for a satellite. So the payload only takes up one portion of this, and as you can see, this product fits very well inside even the smallest CubeSat configurations. On top of that, because there's the same microcontroller on any type of sensor usage, it creates a static interface API, which allows for the software team to have very little trouble switching from one sensor to the other. Why? It's because the product maintains the same type of microcontroller, which means that you have the same type of coding interface and very similar initialization systems. This allows the software team to focus on using the sensor's data rather than trying to implement different types of microcontrollers. Secondly, it has a huge sensor support, has multi-sensor support. Why? Because it uses 6 pins, that's enough for almost every communication system, from SPI to I2C. Specifically in this case, I'm using a SIPM, which uses I2C based communication. And with that communication, we still have 2 pins left over for any type of enable that we want to implement in the future. This CubeSat product is different from what already exists on the market because aside from this, there are no other generic, off-the-shelf, pre-packaged payload solutions. On top of that, it is relatively low cost and has a high data yield because we use some of the most industry standard microcontrollers on the market. Lastly, it integrates well with any CubeSat design. When I came up with this design initially, the first thing that I wanted to make sure was that it hadn't been done already. So I checked on websites like Google Patent and USPTO to make sure of this. I used keywords like modular CubeSat payload, CubeSat sensor suite, and plug-and-play CubeSat sensors. Through my research, I found various integration support, but didn't find any all-in-one ready-to-be-used payload solutions like mine. Second, I went and talked to industry professionals, specifically Michael Quach, who's an advisor for the Cal Poly Pomona Bronco Space CubeSat team, and Sam Yu from Love and Space, who also mentors a lot of college and high school CubeSat teams. Both of these people said that this idea was completely radical and has a lot of potential if implemented correctly. Lastly, I checked on Google to see if there were other existing solutions that were similar to mine. From my research, what I found was that other modular payloads required huge PCB design or manufacturing costs, which is not really accessible for small CubeSat teams. if it didn't require a lot of electronics knowledge and preparation, it would instead have a bunch of moving parts in which the team would need to learn a whole new system just to integrate that type of payload. I hope to expand this project by introducing a whole slew of sensors, from radiometers to hyperspectral imagers, and from what exists right now, this right here is an example of a gamma detector, which detects gamma rays from the sun. Moreover, I hope to increase the processing power of my CubeSat, of my RadCube, by changing the microcontroller from an Arduino-based architecture to STM32-based architecture, which will allow for way higher polling rates, and it'll allow for a more seamless transition between sensors. Thank you for listening.